Welcome to clickmyproject.com.
Now we discuss about a Pan-Sharpening based on the non-subsampled Contourlet transform application to World View to Imaginary. Recently, several Pan-Sharpening methods were proposed and are based on the multi-resolution approach of the Laplacian pyramid. The wavelet transform and the Contourlet transform. The wavelet transform is widely used in Pan-Sharpening due to its properties such as multi-resolution, localization, critical sampling, and limited directionally. However, it fails to capture the smoothness along the counter. Contourlet transform seems to overcome this drawback in the fact Contourlet transform is a multi-resolution transform that provides on wavelet properties. Thus, the Contourlet transform has been used for image fusion and Pan-Sharpening. The non-subsampled Contourlet transform is the invariant version of Contourlet transformation. Nowadays, the application of multispectral image Pan-Sharpening algorithm in remote sensing has become numerous due mainly to the growing number of satellite sensors. Up to now, a large collection of Pan-Sharpening methods have been proposed to improve the multispectral images to high resolution using special information of the pan image. Among them, algorithm based on the widely used intensity hue saturation transform. They produce high special resolution multispectral images, but with color distortion, especially in vegetation areas. The proposed method uses the normalized different vegetation index to correct pan-sharped images. In this process, Pan-Sharpening is a common post-processing operation for captured multispectral satellite imagery. The special resolution of the images gathered in various spectral bands is enhanced by fusing them with a pan-chromatic image captured at a higher resolution. Sharpening methods based on the non-subsampled Contourlet transformer are proposed. NSCT is very efficient representing the directional information and capturing intersonic geometrical structure of the objects. Two pan-sharpening methods based on the non-subsampled Contourlet transformer are proposed. Non-subsampled Contourlet transformer is very efficient in representing the directional information and capturing intersonic geometric structures of the objects. It has characteristics of high resolution, shift invariance, and the high directionality. In the proposed method, a given number of decomposition levels are used to multispectral images, while a higher number of decomposition levels are used for pan image relatively to the ratio of the pan pixel size to the multispectral pixel size. This preserves both spectral and pixel quality while decreasing computation time. Moreover, upsampling of multispectral images is performed after non-subsampled Contourlet transformer and not before by applying the upsampling after non-Contourlet subsampled Contourlet transformer structure, and detailed information of the multispectral images are more likely to be preserved and thus stay more recognizable. Hence, we propose to explore this property in Pan-Sharpening by fusing it with detailed information provided by the pan image in the same fine level. Now it is the multispectral image and the pan image, and here the multispectral image will be decomposed and at the same time the pan image will be decomposed. During the decomposition, the image pixels will be converted to the like a signal processing. Now that signals will be shift the pixels from MS to pan image. So the pan image resolution will be increases based on the MS pixel changing. But here the MS pixels, the hue saturation intensity will be changing. So that reason the pan image pixel information not changing, but the pixel resolution value will be increases. After the shift the pixel, the image will be in the signal format, and then we reconstruct the signal by the image, and we finally getting the pan image. Here we use the non-subsampled Contourlet transformer to decompose and reconstruct the image, and then the shifting pixel will be also using that transformation. The non-subsampled controller transform is a very well algorithm to for making a pan-sharpening image by using the multispectral image. Now we see about demo of our process. Open the MATLAB source code and then right click the main.m source code and run the file. Now the process guide will be open and browse the input dataset from the data folder. Now it is the multispectral band 1 and it is the multispectral buff band 2 and it is the multispectral image band 3 and it is the multispectral image band 4 and it is the pan image and it is the multiband image. Now we decompose the both multispectral image and also the pan image, and during the decomposition it will take some more time for the process. And it is the decomposition result of multispectral image and it is the decomposition result of band image. Here we will extract the information about the both images. After decomposition, then shifting the color from multispectral image to band image. Now the image will be shifting the color between multispectral band to pan-sharpening image. Then we go to reconstruct the image for getting the final result, and it is the output image. Here we reconstruct the image and it is the pan-sharpening image band 1, band 2, band 3, band 4, and it is the multispectral image and it is the pan-sharpening image. Here the pan-sharpening image will be getting the color value getting from the multispectral image. So the given input pan-sharpening image will be changing as the output pan-sharpening image. And now we are going to analyze the process for identifying whether our algorithm will be working correctly or not. Now click the analysis button for the analysis the process. Here the correlation coefficient is 0.1 and the ERGE is 2.57 and the QAV is 0.96 and all values shows whether our algorithm will be working at better result, and the output pan-sharpening image getting the high accuracy result compared to the existing method.